Welcome back, everyone. It's a balmy 58 degrees in the shop today, and I need to get this thing done. This is an Atwater Kent Model 558 that I picked up from a fellow club member and promised him that I would get it working. It was pretty trashed. Apparently it had been sitting since the 1970s. It had a little bit of work done to it. I'll throw some of the photos up from the top. I think I have some top side of the chassis pictures and some underside shots. Atwater Kent, along with other manufacturers during this time, was using early rubber-coated wire. And just like any set you come across with rubber-coated wire, it all had hardened and disintegrated. Also pretty bad was that all of the grid caps for the tubes in here, and there are at least 4, 5, yeah, there are 5, all of them had snapped off. So I had a little bit of parts hunting to do. I found a company in Canada, Maritime, or Maritune Radios, I think, and they had a new old stock grid caps, bought a few of those to put on there. I completely rewired the chassis. I mean, every single piece of wire on this is brand new, every single resistor, and every single capacitor is brand new. The whole 9 yards. And that includes going into, and I'll bring you in a little bit here, the 558, and I'm sure plenty of the other Atwater Kent models from the early 30s here. I think this is about 33, 34, I can't remember which. These two cans here are our intermediate frequency transformers. In this can hiding back here is our audio frequency transformer, coupling between the detector stage and the power stage, which I believe is is it a 42 or a 47? It's a 47, which is this big guy back here. It's got an 80 rectifier. Most of the rest of these are like 55s, 56s, that sort of thing. It did have the power transformer replaced with a stand core at some point. The installation wasn't that bad. It did have a really gnarly power cord tacked into it with friction tape. And what's interesting about this set is one of the extra things it has is this. This potentiometer hanging off with these 3 wires here, this is the silencer control, and this is 20,000 ohms. This is a 4-watt unit. I don't know what the original was rated at, but the original was a wire wound, it had an open winding, and it was junk. And that was killing some of the performance because this potentiometer controls the grid bias of the silencer tube, which is a 57. That is actually part of the plate current path for the detector tube. So you can alter the amount of current, you can limit it going through there. Apparently to help with the automatic volume control, you could snub really powerful stations by just turning down how much plate current gets through. It's an interesting idea. But I had to replace that. The wiring they had used to fix the one that was there was 12-gauge stranded household wire, and it was pretty poorly installed, and it was a mess. And I went through the whole thing. I depotted the audio frequency transformer because this was installed with tar. Put all new wires to the intermediate frequency transformers, and I matched the color code and everything. The tuning condenser got a bath, and the shield above it, which had been used as a handle, it had been bent pretty severely. I took to work, put in my our hydraulic press, put it back into an L shape, and then found a paint that was relatively close to the gold copper color that Atwater Kent was using on the tube shields. So that came out okay. I think it's a little bit darker, a little more copper than gold. What? Hmm? Yes? I'm in the middle of something. Okay? Mm-hmm. Anyway. Oh, one other thing. A lot of these Atwater Kents, and I'm sure other radios of the period had it, the tuning mechanism on this it's not gear driven. You have a friction fit between a piece of rubber that wraps around the shaft back inside here. It's hard to see. And the end of the tuning condenser dial actually has teeth on it. I might be able to show that. So you have these serrations on the edge here, and this nice lovely counterweight. Those serrations are pressing into this little piece of rubber that's captured on the shaft here. In this case, and what most people have done, is to just use automotive fuel hose. I believe this is standard 3/8 diameter hose. That might seem a little big, but once you get it on the shaft, it holds itself in place. You don't have to glue it. And I did clean the shaft up. I took it off, I stuck it in my lathe, and I polished it up a little bit with some fine grit sandpaper and burnished it. And yeah, also disinfected the chassis because it had a lot of dust on it. New power cord, all that good stuff. But the main problem I was having with this was the alignment. It would receive. After I got it completely rewired, I did nothing else but turn it on and make sure that the filament circuits worked, that the plate supplies worked, and I actually received a few stations. I was impressed because I thought I'd screwed something up. I was careful, but you never know. There could always be an issue. You forget to solder a joint, and it's happened before. But I was impressed. It worked, but the response on the low end of the band was poor. I couldn't hear a lot of local stations that came in very clearly on other sets that I own. So I wanted to do a little bit of investigative work. I tried aligning it, and the alignment just made the whole thing go to absolute hell. I was getting whistling on all the stations, heterodyning on any station I tried to tune into. If I aligned it the way I was told to do, and I'll explain that in a minute, the high end of the band, I would get images of all the major radio stations popping up 2 or 3 different places, in addition to obnoxious buzzing and heterodyning, and it just generally sounded horrible. Nothing below about 1,000 kilohertz was listenable. It was all just gibberish. So that was a bit demoralizing, and I worked on it off and on for about 2 weeks, not getting anywhere. Until 2 days ago, when, after fiddling with it for the umpteenth time and trying to align it with the Precision E-200-C that I cleaned up in the last video, I realized something. There were 3 very obvious clues for what the problem with this set is, and we're going to go over them in sequence. Clue number the first, the chassis of this, inside here, we have a bit of a spaghetti mess, honestly. I think a lot of radios from this period look like this. The wiring just kind of goes everywhere. Atwater Kent liked to use these cardboard toilet paper tube assemblies to hold resistors on and then run all the wires to them. That was a little tricky. I reused them. There was also a large multi-section capacitor can bolted right here that all the wires ran to. Packing all the new ones into that would have been a nightmare. There were over 10 of them in there. It just wouldn't have worked. So I put them discreetly in the independent places per the schematic where they should go and made new grounds for them, because they're mostly bypass caps. Anyway, first clue, these 2 coils right here. Coil on the left is our antenna coil. Coil on the right is our oscillator coil. When I opened the set originally, these 2 were just sitting out here in the open, nothing wrapped around them. And I didn't think anything of it. Really stupid in hindsight. So they were just sitting there, about 2 inches apart. Now, if you know anything about electromagnetics, 2 coils sitting that close to each other, and they're both facing the same direction, means that the field for one can very easily couple to the field of the other. In this case, the oscillator coil could pretty easily couple to the field of the antenna coil, and you get a wonderful feedback loop of nonsense. That occurred to me briefly, but then I thought, well, it looks like it's the way it left the factory, so whatever, I'm just going to leave it alone. Well, at no point did it occur to me that there probably should have been a shield around them. And it should have been apparent because, and I'm not going to take these off because getting them fit on there, I had to fabricate these from scratch. Getting them to fit on there was a bit tight. I had to make them out of aluminum shingle flashing and pop rivets. So they're on there and I'm not removing them. But there is a base around each of the coils with fingers, and the fingers have cutouts in them for the wiring to pass through. I just thought that was a convenience to let the wiring lay against the chassis to prevent coupling. I did not consider that was when you put the shield over it, the wires have somewhere to go instead of having to put holes in the shield. So, didn't get that. I just assumed the coils were the way they are, and I thought it was just a poor design decision on Atwater Kent's part. The second clue... Well, yeah, sorry. Second clue was the bases. First clue was the coils are really close together. Clue number 2 was there are obvious bases designed to hold something. I did not grasp that. The third and final clue, and what really made me figure it out, was the schematic. And this is my copy of riders here. And Atwater Kent schematics from this era are some of my least favorite because unless you have the riders, they do not list part values. So, good luck. Riders had to pencil them all in. Kind of hard to see. But the coils that we care about are the antenna coil, called the number 1 radio frequency transformer over here, and the oscillator coil called the, is it the number 2 radio frequency transformer? Yeah, something like that. So this guy here and this guy here. As is typical with components that are shielded, there is a very obvious dotted black line around the entire thing, just like every other coil that is inside a metal can. At no point during my rebuild of this set did I even look at those and consider the fact that those coils were supposed to be covered. Now, in my defense, the coils covers were missing. When I got the set, it had been worked on at some point, probably in the 70s or so, poorly. And more likely than not, someone pulled the shields off of it. Now, I don't know why you would do that, because none of the wiring going to these transformers was disturbed. It was purely the power cord and the connections for the silencer control. So, the fact that these were ditched is odd to me. But what I ultimately did when I saw the schematic and it clicked, I took just an aluminum can and I flipped the radio on and I held it over the antenna coil, and about halfway down, all the whistling went away and all the stations came back clear. And that was about all the convincing that I needed. So, I always get stumped by the stupidest things. Don't ever feel bad if you're working on something and it turns out to be a simple fix. I have gone through 2 of those this week, one at work, one at home. It happens a lot. There's always some little detail you overlook because you think it's got to be something more complicated. So don't worry about it, because it's probably something dumb like this. Or I should say, don't worry about it if it is something dumb like that, because it happens. Anyway, what I want to do today, because I have exactly 1 week before I need to get this back. I missed the first deadline because I couldn't get it aligned. The Christmas party for the club is coming up on the 10th, which means I need to have this up and running fully for Mr. McKenzie. And that is not wanting to plug in very nicely. The outlets on this panel are kind of, they're old. And I need to replace them. Whatever. So, we'll get that fired up, I'll get my signal generator activated, and I have my grandfather's vacuum tube voltmeter up there for monitoring the audio level. For the audio level connection on this, actually, what I'm doing is attaching the leads from this guy here, one to ground, and the other to a tab on the tone control. Because the tone control actually connects directly to the secondary winding of the audio transformer, so we'll be getting a low voltage AC signal that's directly, it scales correctly for checking the alignment. That was the easiest point for me to pick off rather than trying to hunt around or trying to get into the audio circuit for the speaker. I just went straight from the interstage audio transformer. It was just simple. But I need to let these warm up. Generally, if I'm aligning something, you want to let the whole thing get up to temperature. I'm warming the room up because it's going to help with that. But we want to make sure that everything here has a chance to normalize. The tubes, the components underneath the chassis, everything. Get everything to just nicely warm up, and then I'll go through and adjust it. Now, as far as the adjustment procedure on this set goes, there's the usual IF junk. So we take the lids off of these cans over here. That one there, and this one here. And just kind of set the lid out of the way. There are 2 adjustments in each one. A little hard to see. So there's pointing device. One there, and it's mirrored over in the other can. From the factory, these apparently came with a small blob of paint to keep them locked in one position. It looks like these were already messed with when I got to them, so yeah, it's just how it was. So I believe this is actually our second IF stage, and this is our first back here. The way you're supposed to align this apparently is we go in, and how I have done it in the past, you go in from the tube that's tucked back here. There's a grid cap coming off the condenser. This is our first input stage. We couple into that with the signal generator, tune the back end first, then tune the front end, and then we'll go through the trimmers that are on the top here, which are peaking a number of smaller tuned circuits in the set. And the first one we have to do is this guy third from the front, which is the oscillator. This is going to set our tracking. So in this case, we are going to set the dial to 1500 kilohertz, all the way up here. Make sure the needle is hovering over it. I'll feed in a 1500 kilocycle signal from the signal generator. We'll peak that for maximum output. And then once that is done, we go through with the first trimmer, second trimmer, and then the third trimmer all the way to the back in sequence. And I'm used to, on other more complicated sets from the late 30s, where each of the different trimmers has to be peaked at a very specific frequency for very specific reasons. In this case, all of these are going to be peaked at 1500 kilocycles. Do the oscillator first for tracking, do the other three after it, because apparently some of these are for like the antenna circuit for eliminating images on the band, or image rejection, I should say. And yeah, so overall, pretty simple. I could not find any of this actually written down anywhere, though. I had to ask for help on the Antique Radio forum, and that was the instructions that I got. I understand that they do work, but it is a little frustrating working with Atwater Kent in that some of these radios just don't have printed data available, either because it was never written down or the documentation was destroyed. I don't know, either way. That's all we got to do for this, and my fingers crossed everything comes out fine. Now, while it's warming up, we can actually listen to it and see how we do right now. I'm using a spool of solder as a makeshift antenna because I can unroll it to any length I need. And let's see what we get off the bat. Turn the volume up here. Oop. You can see we're getting it in more than one place. It's pretty powerful, so tuning it should help with rejecting that image.
Negotiations over border security and foreign aid, but first, your party's leading candidate.
Still a little bit of whistling there.
15th. According to witnesses, the incident started after Breonna Brown, a sophomore, confronted a separate.
You are determined to get seen. You better tell me that was a blown coverage or somebody just fell off. $400 a day. It's a taxable event.
Okay, so we get quite a few stations across the band, but we do get an image or two on the high end. From what I've read, that tends to happen with high power stations. It's a little tricky to reject the image, but again, that's what tuning these circuits in here should help do, is clean it up and, more importantly, improve the tracking so that the numbers on the dial do correctly correspond with what we are trying to tune in, because if the oscillator is off, we could be tuning in 1000 kilohertz all the way up to 110 or down to 95, who knows. But I'm going to let these sit for about a half hour or so to get normalized, and then I will come back and it should be a pretty straightforward procedure. Okay, so I've given the assemblies here sufficient time to warm up and get ready. The transformer is making a pretty nice hand warmer actually, so a little bit chilly in here. And we're going to clip into the head end of the radio here. Going to briefly disconnect our antenna. There we go. And we need to set the signal gen for band A. Modulated RF. I think I was using about 50% modulation. And that was working out alright. And we're going to spin the RF controls up so we can hear it. And alright, so 130 kilocycles is right there. Now it's hard to see, but voltmeter up there is on the 1.5 volt AC setting, and if I crank up the volume, you can see it budge there. I'm going to see how good we can get that, starting at the back end first. We're probably already pretty close to peaked on these because I've done them a number of times. If I can get it to actually sit in there, we go. Yep. I'm having issues with the entire assembly trying to rotate on me. Okay, that's about as good as that's going to get. And we'll go front end. Alright, that one's pretty well peaked. And then the last one here. Yeah, I think that's about as good as we're going to get. I'll go ahead and put the shields back on it. I didn't think the IF would change much between all the times I've been messing with it, but it was worth the test. And we're going to go up to the C band, and we're going to spin this up to 1500 kilocycles, right about there. We should hear it. Ah, but we don't. That's a good indicator that we are not we're not tracking correctly, so the oscillator is probably a mile off. Alright. Let's go see if we can find it. So, third one down, this is the oscillator connection. Hammond band C, correct? Yes. Oh, whoops. I don't want to go in through the IF stage for this. I want to go in through the antenna for doing the radio frequency level signals. Duh. Alright. There it is. Alright, that's about as strong as it's going to get on the oscillator. Now let's peek front. Number 1 trimmer. It's about right there. Number 2 trimmer. About right there. And the number 3 trimmer. Save my eardrums a little bit. About that. Okay. So that seems to be pretty good. Now what I want to check is dial accuracy. Right now we're setting at 1500. Let's tune it down. I'm going to turn this down just a bit. Let's tune it down to... Alright, there's 1400. Do we get 1400? Sort of. Okay, how about... Oops, sorry. How about 13? Seems a little off to me. Just a little bit behind there. Okay. Well, how about 1000? I'm pretty sure I did that correctly. Followed the instructions exactly how they specified. Yeah, I'm seeing the response. With the dial at 1000, the signal generator is showing it as being maybe 950 plus. I mean, maybe I can't expect super duper accuracy with this, but it is still a little annoying. Set to 800. Well, I'll tell you what. Let's just try and see what we get picked up. I'll use the major radio stations as a an indicator of accuracy. How about that?
Thank you so much for your time and insight. Thanks for having me. Still to come, House Republicans get one of their own.
That sounds substantially worse to my ears. I don't know. I was kind of hoping that would go a lot more smoothly, and it is not.
And the NFL logo at the
And that's a terrible mistake.
Okay, after fiddling with the generator and fiddling with the chassis and listening to my pocket transistor set here, I finally nailed it. The instructions that I was given by the fine folks on the forum was that I needed to set the generator to 1500 kilocycles, align the needle on the dial to the 150 mark, and use that as the reference point. But they also stated that you wanted to adjust the high end of the band with the tuning condenser fully open. However, on this radio, these two limits here do not represent the maximum bounds of the tuning condenser. If I open it all the way, it comes completely off the scale. So my question was, at that point, what is that frequency, give or take? Why shouldn't I be aligning it there? So the first thing I tried was opening it all the way, setting it to 1500 kilocycles, and then aligning it again. The result was I got a lot more stations. Things seemed to be more spread out, but they obviously didn't line up. But it was a lot better. So I thought, or actually no, they were a little more crushed together. It didn't quite work that well. So I thought, okay, well, I'm above 150, 150 kilocycles. So, 1500 kilocycles. So let's estimate. At first I tried 1600 because it's a little ahead of that. But looking at the spacing, and I'm sorry for keeping you so far away from the dial here. Looking at the spacing, if our needle is down here, and that's maximum open, and 150 is here, then presumably this should be about 1700, which tends to be the upper end on a lot of AM receivers in the 30s, about 500 to 1700, because I think, once you get that high, you do start to pick up some of the police stuff, or at least you used to be able to, and then above that was shortwave. So I set the signal generator for 1700 kilocycles. I completely opened the tuning condenser. I peaked everything exactly the way I had before, and the results were stupendous. So, just to give you a listen across the band here, and I gotta be careful with the volume.
Radio, so radio
So we start there.
Over the Thanksgiving holiday, news reported last week the department only charged 17%. A rare and underdiagnosed.
More importantly, we have Como. We finally have Como, and it is directly on 1,000.
ConnectToYourHeart.com, sponsored by Pfizer. The Pro Bowl games are taking over.
But more importantly, I was able to corroborate every single station that I can hear on this with this transistor portable. So if I flip the volume up here, and we tune over to 1,000.
Football finale at Camping World Stadium. Be there live and soak up football fun in the sun all weekend long. The Pro Bowl games presented by Verizon, Sunday, February 4th. Go to probowl.com/tickets to get yours today.
Okay, so we have it on 1,000. How about we go up? So that's about 1,100 or so.
Number to survivors. They are only charging 17% of cases.
It depends on how you look at it, Chris.
Okay. At 120 we have this. A little above 120. I'm working with a really tiny dial here, so it's hard to tell where I am exactly. So the upper end of the dial is tracking nicely. Let's go and check out everything below 1,000. So below 1,000.
I know you're probably saying, Bill Black, what does Anita Baker have to do with the Boomerang soundtrack? I'll tell you.
So that's about 90-ish.
Boomerang motion picture soundtrack. They even submitted
Right on 90.
to Anita Baker.
At the time, Anita declined the songs because...
Okay, how about...
Down it between the 7 with 8-yard lines along the near side.
That's below 80, so probably around 75 or so.
To make it a 92-yard field here for the Bucks, who are up 7-3 with 5:50 to go.
And there hasn't been much to speak of in the air today for either team. For Baker Mayfield, the Tampa Bay quarterback, he's 4 of 11 for 53 yards, but you'll recall 40 of those yards
All right.
on one throw to Mike Evans.
What else we got? There's a very faint Christmas channel. I wonder if we can get that.
Speak of outside of a couple of... More.
Yeah, there it is right there. It's really faint, but it is picking it up. And lastly...
Pay off the mortgage. Feel better. And it's okay to do that. Do that. And then, oh, thank you.
somewhere around 55, we should get that channel.
I feel free. And freedom is an important emotion to encourage. So just because on paper the computer, if we were doing AI...
And there we go. Problem solved. So, I guess the moral of the story is, if you're working on a 558 chassis, I'm assuming this would probably also work for the 558D and the 558Q. They have the same basic setup, but slightly different tube complements. The circuits are mostly the same, silencer control and all that. My recommendation is, based on personal experience, peak the IFs, open the tuning condenser all the way, set your signal generator for 1700 kilocycles, peak the oscillator, and then peak the 3 trimmers. And that should give you proper dial tracking, at least as far as this test run goes here. So this is fantastic. A lot of weight off, my shoulders, because I have been desperately trying to figure out what's been going on with this. But I am super happy, and I am sure the owner will be happy too.
Red hot fire protection is 50. Not going to be a first down to the 49-yard line.
And there's tone control. Oh, and I suppose I should show off the silencer control. So it's all the way up right now. However, if I turn the volume on
When the ball was snapped, and I think that was the over the middle. Rams did not have.
So I can snub that down. If we go back to that high-powered Hispanic station, it's still pretty powerful. But it's an interesting feature.
Yeah, that's a shame if you're the Cleveland Browns.
But I think that'll do it for this. The signal generator works exactly like it ought to. It's accurate, and yeah, the Atwater Kent is good to go. So I will get that packaged back up in its cabinet. Cabinet, interestingly, also has, I'm guessing it's steel. There's a steel sheet nailed inside here that acts as an RF shield for the bottom, which is kind of neat. One thing I will say is I would not try aligning this set while it's inside the cabinet, because these trimmers are totally inaccessible thanks to the speaker, the electromagnet for the speaker being directly over it, so you're going to have to pull the chassis out, flip it around to plug the speaker back in to do the alignment. But not that bad. And yeah, I think that's going to do it for this one. Expectations were met, problems were solved, and I can finally make some more space on my bench, because this thing has been occupying a lot of the room here. So I'm going to get this back to the owner on the 10th, and then we'll find something else to work on. I have a whole pile of things that I would like to start messing with. My own personal stuff, for once. So, thanks for watching, and I'll see you in the next one.